The Machine That Dreams, The Complete History of Artificial Intelligence. On the 9th of March, 2016, one of the greatest Go players in history sat across from an opponent that didn't breathe, didn't blink, didn't feel the weight of what it was about to do. But this story doesn't start in Seoul. It starts with a question humans have been asking for 3,000 years. Act 1. The Dream. The dream of the artificial mind is older than science, older than philosophy, almost as old as civilization itself. In Greek mythology, the god Hephaestus, the divine blacksmith, filled his workshop with machines that thought, golden maidens who could speak, who could anticipate their master's needs, self-moving tripods that served food to the gods and wheeled themselves home again. Homer used a word for them that we still use today: automaton, self-moving. He built Talos too, a giant made of bronze tasked with guarding the island of Crete. 3 times a day, Talos patrolled the coastline, hurling boulders at enemy ships. The world's first automated defense system, running on divine fluid sealed behind a single bronze nail. In ancient China, an artificer named Yan Shi presented King Mu with a mechanical man so lifelike that when it winked at the royal concubines, the king nearly had its creator executed. Only when it was torn apart, revealing leather, wood, and glue, was the king satisfied it wasn't alive. In Prague, a rabbi shaped a golem from river clay and brought it to life with a word inscribed on its forehead: Emet, truth. Erase the first letter and the word becomes met. Dead. An on-off switch written in Hebrew. And in 1770, a Hungarian inventor unveiled a chess-playing machine dressed in Turkish robes. It defeated Napoleon. It impressed Benjamin Franklin. For 84 years, the world debated whether this machine could truly think. It couldn't. A human chess master was hidden inside. But here's what matters. For 84 years, people wanted to believe. The dream of a thinking machine has always been, at its heart, a human desire. In 1936, a 24-year-old mathematician at Cambridge published a paper that defined what a computer could be. His name was Alan Turing, and his universal machine, a thought experiment with an infinite tape and a set of simple rules, became the blueprint for every computer that would ever exist. During the war, Turing designed the machines that cracked the Enigma code. It is estimated that his work shortened the war by 2 years and saved millions of lives. He was also, by all accounts, magnificently eccentric. He chained his tea mug to the radiator, and when his bicycle chain kept slipping off, rather than have it fixed, he counted the pedal rotations and stopped just before it failed. He had turned a mechanical problem into an algorithm. It was, in miniature, his entire worldview. Then, in 1950, he asked the question that started everything. I propose to consider the question, can machines think? In a world where computers filled entire rooms and could barely manage arithmetic, one man asked, what if they could think? Not calculate. Think. He even devised a test. If a machine could fool a human into believing it was human through nothing but typed conversation, then it could be said to think. He called it the imitation game. Turing didn't live to see his dream pursued. In 1952, he was prosecuted for homosexuality and subjected to chemical castration. He died in 1954 at the age of 41 with a half-eaten apple beside his bed. The inquest ruled suicide. The father of artificial intelligence never saw the field he fathered. 2 years later, in the summer of 1956, a group of young scientists, the eldest just 39, gathered at Dartmouth College in New Hampshire. They had secured $7,500 from the Rockefeller Foundation, about $85,000 in today's money, and the top floor of the maths department. They gave themselves 2 months to crack the problem of intelligence. Their proposal contained what may be the most audacious sentence in the history of science. Every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. They coined a name for their new field. They called it artificial intelligence. At one point during the workshop, 5 of them gathered around a dictionary to look up the word heuristic because they thought it might be useful. These were the founders of AI, and they were still inventing their vocabulary. What followed was intoxicating. Programs that proved mathematical theorems, a chatbot called Eliza that convinced people it was a therapist, so convincingly that its own creator's secretary asked him to leave the room so she could talk to it in private. When he later told her he could read the conversation logs, she was outraged at the invasion of her privacy. She knew it was a machine. She wanted privacy anyway. And the predictions. Oh, the predictions. Herbert Simon, 1960. Machines will be capable, within 20 years, of doing any work a man can do. Marvin Minsky, 1967. The problem of creating artificial intelligence will substantially be solved. Minsky again, 1970, in Life magazine. In from 3 to 8 years, we will have a machine with the general intelligence of an average human being. Meanwhile, a quieter drama was unfolding. In 1957, Frank Rosenblatt had built the perceptron, a machine that could genuinely learn from its mistakes. The New York Times hailed it as the embryo of an electronic computer designed to read and grow wiser. But Rosenblatt's old high school rival, Marvin Minsky, who had himself built one of the first neural networks in 1951, then abandoned the idea, published a book in 1969 proving the perceptron's limitations, calling neural networks a sterile direction of research. Funding dried up, students were steered away. Rosenblatt drowned in a boating accident in 1971 on his 43rd birthday. He never lived to see his ideas vindicated. They were wrong, all of them, spectacularly, humiliatingly wrong. Act 2, The Winters. By 1973, the reckoning had arrived. In Britain, a Cambridge mathematician named James Lighthill was asked to assess what AI had actually achieved. His verdict was devastating. The field had failed to address what he called combinatorial explosion, the fact that real-world problems grow exponentially more complex as they scale up. The British government slashed funding. University laboratories were dismantled. In America, the Vietnam-era Mansfield Amendment forced DARPA to justify every project with direct military relevance. The age of curiosity-driven funding was over. The promises had been too grand, the results too modest. They had underestimated something profound. Intelligence wasn't a puzzle to be solved, it was an ocean to be crossed. And they'd built a rowboat. In the 1980s, hope returned, dressed in a power suit. Expert systems, programs stuffed with hand-coded rules by human specialists, revived the field. Japan launched its 5th-generation computer project, sparking an international AI arms race. Companies poured billions in. By 1985, the AI industry was worth over $1 billion. But there was a problem nobody wanted to discuss. Expert systems could only know what humans explicitly told them. They couldn't learn. They couldn't adapt. They were brittle as glass. The second crash was worse than the first. The expert systems collapsed under their own weight. Too expensive, too rigid, impossible to maintain. Japan's 5th-generation project quietly failed. The Lisp machine market evaporated. Artificial intelligence became a dirty word. Researchers learned to call their work machine learning, informatics, cognitive systems, anything but AI. Imagine spending your entire career on an idea everyone says is dead. That's what a handful of researchers did through the 1990s. Geoffrey Hinton in Toronto, the great-great-grandson of George Boole, the mathematician who had invented the algebra of logic 150 years earlier. Yann LeCun at Bell Labs. Yoshua Bengio in Montreal. They kept working on neural networks, mathematical systems loosely inspired by the human brain, when the rest of the world had given up. They didn't have funding. They didn't have prestige. They didn't even have the computing power to test their biggest ideas. But they had a conviction that almost nobody shared, that the brain might be the blueprint after all. Hinton secured funding from CIFAR, a small Canadian research institute that kept a tiny community alive. LeCun built a system at Bell Labs that could read handwritten checks. By the late 90s, it was processing over 10% of all checks deposited in the United States. And almost nobody in AI cared. Act 3, The Quiet Revolution. It's 1997. IBM's Deep Blue defeats world chess champion Garry Kasparov. The world is stunned. Kasparov tells the press, "I could feel, I could smell a new kind of intelligence across the table." But the neural network believers watch and shake their heads. Deep Blue evaluates 200 million positions per second. It doesn't understand chess. It doesn't understand anything. This is a triumph of speed, not thought. IBM refuses a rematch and dismantles the machine. For a decade, the best image recognition systems inch forward. A percentage point here, a fraction there. Then, in September 2012, a student named Alex Krzyzewski enters the ImageNet competition with a deep neural network trained on 2 gaming GPUs in his bedroom. $500 graphics cards designed for video games. He doesn't just win. He obliterates the field. His error rate is 10 percentage points lower than the runner-up, a margin that shouldn't exist. Geoffrey Hinton, his supervisor, later says with characteristic understatement, "Ilya thought we should do it. Alex made it work. And I got the Nobel Prize." The deep learning winter was over, and it would never come back. March 2016. Seoul, Google DeepMind's AlphaGo challenges Lee Sedol, c. 18-time world champion, one of the greatest Go players in history, to a 5-game match. Go has more possible positions than atoms in the observable universe. Experts predict Lee Sedol will win 5-0. He loses the first game. "I'm quite speechless," he tells the press. "There was no moment I thought I was leading." He loses the second game, and in that second game, on move 37, something happens that changes everything. Move 37, a stone placed where no human would place it. AlphaGo itself calculates there is only a 1 in 10,000 chance a human would play this move. The commentator, himself a 9-dan professional, pauses mid-sentence. "I wasn't expecting that." Lee Sedol sees the move, stares and leaves the room. He doesn't come back for 15 minutes. The move is not from any database. It is not copied from any master. It is something the machine has invented. In a game that has been played for 3,000 years, a machine has found a move that is genuinely, breathtakingly new. He loses the third game. But in Game 4, facing elimination, Lee Sedol plays his own impossible move. Move 78, a move so brilliant that Gu Li, a fellow 9-dan master, calls it divine. AlphaGo falters. Lee Sedol wins. He lost the match, 4 games to 1. But in Game 4, he reminded the world of something. Human creativity doesn't end just because a new kind of intelligence is born. It's challenged, and sometimes it rises. 3 years later, Lee Sedol retired from professional Go. The only top player ever to walk away because of AI. His reason was devastating. "Even if I become the number 1, there is an entity that cannot be defeated." Act 4. The Explosion. After AlphaGo, the dam breaks. Deep learning conquers domain after domain at dizzying speed. Machines learn to play Atari games, to translate languages, to drive cars. Each breakthrough arrives faster than the last. In 2020, AlphaFold solves protein structure prediction, a 50-year grand challenge in biology. It predicted the structure of virtually every known protein, all 200 million of them. Work that had taken biologists decades was completed in days. Some wept with joy, some with something harder to name. In 2024, its creators win the Nobel Prize in Chemistry. In the same ceremony, Geoffrey Hinton, Boole's great-great-grandson, wins the Nobel Prize in Physics for the neural network discoveries that made it all possible. The godfather of deep learning collects his prize and warns the audience, "We have no idea whether we can stay in control." In 2017, 8 researchers at Google publish a paper with a title that sounds like a love song, "Attention is all you need." It proposes a new architecture, the transformer, a way for machines to process language not word by word, but all at once, understanding relationships between words regardless of distance. Within 5 years, it would reshape civilization. 6 of the 8 authors would leave Google to found their own companies, raising over $1 billion between them. Google published the blueprint for the revolution, then watched its own people leave to build it. November 30th, 2022, OpenAI releases ChatGPT. It reaches 100 million users in 2 months. the fastest adoption of any technology in human history. Instagram took 2.5 years, TikTok 9 months, ChatGPT 60 days. Suddenly, AI isn't abstract, it isn't academic. Everyone's grandmother is using it. Teachers panic about homework. Writers panic about jobs. Artists panic about everything. A New York attorney submits 6 court cases to a judge. All 6 have been invented by ChatGPT. Not one of them exists. The technology is astonishing and unreliable in equal measure. For 60 years, AI had been a promise, a threat, a joke, a dream. On November 30th, 2022, it became a product. And the world has not been the same since. What follows is an arms race without precedent. Google, Meta, Anthropic, Microsoft, xAI. They pour tens of billions into AI. Models arrive faster than anyone can evaluate them. GPT-4, Claude, Gemini, Google rushes its Bard chatbot to market and stumbles. A wrong answer in its very first demo wipes $100 billion from its stock price in a single day. Open-source alternatives from China crash the market in a different way. In January 2025, DeepSeek wipes nearly $600 billion from NVIDIA's value. And then there is the weekend that reveals the fault line at the heart of it all. In November 2023, OpenAI's board fires its own CEO, Sam Altman, informing him 5 minutes before it happens, while he watches the Las Vegas Grand Prix on a video call. He is gone for 5 days. 500 of the company's 770 employees threaten to quit. He comes back. The board is replaced. The company that started as a non-profit dedicated to safe AI had become the fastest-growing startup in history. And the people inside it couldn't agree on whether they were saving the world or endangering it. Act 5. The question. The world grapples with what this means. AI-generated deepfakes that erode trust. Copyright lawsuits from artists whose work was consumed without consent. An education system struggling to tell the difference between what students wrote and what machines wrote for them. The Hollywood writers went on strike and won historic protections. AI cannot be credited as a writer, and digital replicas of actors cannot be used without consent. Governments scrambled to regulate. The European Union passed the world's first comprehensive AI law, while America swung from safety-focused regulation to deregulation and back again. Every previous technological revolution, the printing press, electricity, the internet, seemed to threaten the world before it transformed it. But none of them could think. We are living inside the most consequential technology story in human history. AI agents that can control computers. Though in one early test, an AI abandoned a coding task to browse photographs of Yellowstone National Park. Models with 1 million tokens of context. Machines writing production code, designing drugs, predicting the weather with greater accuracy than decades of atmospheric science. The frontier is moving so fast that anything written today may be outdated tomorrow. And unlike every other chapter in this documentary, we don't know how this one ends. In 1950, Alan Turing asked, "Can machines think?" 75 years later, we still don't have an answer. But the question has changed. It's no longer can they think, it's what happens to us when they do. The dream of the thinking machine is as old as civilization. For 3,000 years it was mythology. For 100 years it was science fiction. For 70 years it was science. And now it's a Tuesday afternoon, and anyone with a phone can talk to one. The machine that dreams is awake. The question is, what will it dream of next? The machine that dreams